Dr. Boskovic is a research associate at Imperial College London, focusing on improvement of public health and well-being in cities through the systematic implementation of nature-based technology. Stanislava, the stage is yours.
Thank you very much for the introduction, Hussein. I'm very happy being here with you today, talking about the interventions in complex urban systems. So the climate change related phenomena and all the consequences are putting an enormous strain on urban infrastructure, on its services, and generally on the quality of life of people and on public health and well-being. And the importance from our point of view of scientific understanding of these effects and also of territory as an organic, complex, and multi-scale system with many dimensions that is in constant transition to us seems extremely important. Most importantly for the understanding the true dimension of ecological crisis. So we believe that through the projects that we deal with, we can create this link between the local problems, the regional scale, and also the planetary problems, and use the opportunity to connect nature and society, to connect natural and artificial components of urban systems, to create a dialogue between urban and rural areas of territory through the projects we are dealing with, so that the projects are interconnected in the context. We are working in past and in the future context. So the complexity of the urban systems and is very high, and to address it, we really believe that we have to go beyond the conventional rules of urban design and to introduce the frameworks that will be able to rethink and to contribute to planet's health and people's quality of life that are center of our research at Imperial College. The framework that we are introducing in the project we are dealing with is based on systemic design approach, and it is made for the multifunctional MBSs and the intervention that are based on nature-based solutions. So to start the process of interventions in a complex system, we deal with the knowledge about the purpose of the projects we are doing. And that purpose can be multiple and different. We also call it dynamic because independence of the system we are dealing with, it really defines the purpose that defines then every single step of the process. So first we approach the context of the project we are dealing with. We study the context from the climatic geographical point of view, but also from the social tissue point of view, and that knowledge then goes to the mapping phase. And once we have the purpose definition, we map the key determinant elements of the knowledge of the context we have, and then we are ready to get to the third part of this process, which is analysis of alternatives. If we speak about any new development, for example, then the alternatives would be if we decide to build on greenfield or brownfield, or we really decide to retrofit an existing built environment. And the exploratory models help us through the mapping and through the knowledge of the spatial elements of the area to analyze the alternatives and then produce the options, the possible options, how we can really deal with the task and with the purpose that we are approaching. And through the other models that are helping us with the design of the options, with the simulations, we can define what we call systemic design conditions that really help us to guide the process of the further stages of the design, to inform the decision makers, the urban planning authorities, with an integrated, quantitative and science-based analysis that goes before the phases of the further design. And this knowledge that we gain through the 6 steps that are presented here, including the definition of the purpose, really can make better decisions that might otherwise have not been taken without this analytical process. To give you a couple of examples how we work with this framework, I will show you 2 projects or 2 groups of projects. One is with the defined purpose on water neutrality in City of London, and another one is focused on health and citizens' well-being. So you will see how the framework works in different environments. So with water neutrality concept, we've worked having studied the prospects of the development, future development of housing in London, and knowing that the target that London has is 10 years, it is for the 10 future years, it is about 500,000 of new housing to be built. So being the main focus of the research group and expertise that we have there focused on water, we try to apply the water neutrality concept with this target and hypothesis on 10 years in 500,000 of new homes. So if we apply it, we know that it will have a strong impact on different indicators connected with the water security, which are urban consumer demand, the flood risk, and water quality in the case of our study. And we know that it will have an impact of the water system of the City of London that are shown in these numbers in percentages. And to fully upset the development, not only we have to introduce the design options that are taking in account the blue-green infrastructure, which would definitely reduce the impact respect to business as usual, but to reach this blue line of the neutrality, we would need also to retrofit more than 400,000 existing homes, and also to add a significant amount of blue-green space, almost 20 kilometers of square meters, to be able to reach the water neutrality. And to model and simulate this impact, we use different tools that are based on the integrated modeling. We use also the spatial data, which allowed us to calculate the density, the pervious and impervious areas, and how we can distribute the pressures of the impact, and then we can add the possible positive effects of the new options in design based on the blue-green infrastructure, and then we can have the tools for helping in decision makers and seeing the further opportunity. So the integrated modeling in our group is based on CityVault, which deals with the groundwater, with river water, and then goes and calculates the distribution, consumption of water, and already give us the understanding of the changes in water neutrality indicators. And once we have this image, and once we know where the development is located, we can add on with evaluation tools, creating the ranking score, which could help in choosing the most favorable location. And additionally, I will show it on the example on the borough of Enfield, where we are working, that we could test the impact and opportunities scores in some of the already suggested urban development sites, but more than that, we can really help to create what we call virtual decision room, and to suggest which other areas could be also used for an intervention to better offset the impact for the water neutrality. So the system of multi-criteria decision making is the way we are analyzing the allocation. The next step of this work is currently ongoing, and it is focusing not only on where we are allocating in the most favorable position from the point of view of water neutrality, but also how. So we are dealing in this part of the research with the morphology and with the connection, a possible connection of the impacts on water neutrality together with research on the morphology most adapted for the very specific conditions where we are dealing. And it would help us to reduce the subjectiveness in our approach, to inform the decision makers for the future steps. And in this case, we are dealing with water neutrality, but the future work is to link it with other systems like energy and, of course, transport system in the way to best to improve the knowledge of the context and to best inform the future stages of developing of the areas for the targets that are already established. The second group of projects I would like to talk about are two European projects, UPOLIS and HARD, truly multidisciplinary projects that have a focus of health and well-being of citizens in cities. There are very concrete case studies and demonstration sites where some of the solutions based on multifunctional nature-based solutions and nature-inspired solution will be tested and evaluated, hopefully with their positive impact for health and social inclusiveness and well-being of cities that we are testing. As I said, it is a multi-disciplinary project. We have many partners that are going beyond the urban designers, engineers, and other people involved in processes of creating new developments or public spaces, like in this case. But also we work very intensively with the institutes of social studies that are helping us understanding the process of stakeholders' involvement, of stakeholders, both experts and also citizens and future users of the spaces we are dealing with. Additionally, we have a group of experts, medical experts, that are supporting all the process from the very beginning of choosing the interventions and also helping to select the precise indicators that are connected with the expected outcomes of the project and guide us through their discipline lenses of what are the health indicators and the possible improvements of it in our cities. We use different technologies to support the research for having the robust evidence, data evidence on the public health improvement, which is the expected outcome of the project, and as I said. So we started this project having already the list of possible interventions that could be done in different cities. And what is the goal of the analytical part of this project is to see this possible nature-based solution tailored to a local climate and specific social conditions in the cities where we are working, thus to create really inclusive urban spaces and to address the key challenges with environmental quality, water stress, as we saw in other projects, but also to respond on specific local conditions. And how we do it, apart the very detailed studying on the conditions of local plans or the existing projects and existing use of MBSs in the city where we work. We also do the very detailed mapping of the stakeholders and with a very different involvement methodologies. There are a series of workshops that are done. In these images you are seeing in the city of Belgrade, where we explain the intentions of the project to the local citizens, but also we learn from them, from their knowledge, what are the needs and what are the concerns that they are dealing with in everyday life, with the, of course, knowledge of the geographical conditions of the place we are working, in this case the confluence of Sava and water river, that are opening a great potential for interventions that are based on or driven by nature and based on blue-green infrastructure. So being the focus improvement of the social characteristic of the spaces, because in many demo sites we are working with, they are also degraded. Well, the improvement of livability and the more sense of place and responsibility of the works that we are all co-creating here through the improvement of quality of life, but with the focus of public health and well-being, is something that we work in different stages of the project. So we obviously study the environmental impacts of the interventions that we plan to implement, and seeing them through the main challenges in every specific demo site, which are the climate resilience, water quality, as we saw, air quality, biodiversity, and the quality of life of users and citizens, to then connect them with the diseases clusters and to connect them with the precise impact on different groups of diseases. How we then proceed with the choice of the MBS, which is much more complex than just use of one solution. We analyze very well the local conditions to then combine several solutions for specific conditions. We call it a la carte, because we really choose from different categories that are connected with rivers, like in case with Belgrade that you said, on flood risk, or different other categories, to then also add the supporting technologies that could be nowcasting or could be other technologies for metabolic improvement of water quality, to then arrive to the one solution that is modular, composed of all these different elements. And in this stage, we are also testing the possible solution through different means. We have the air quality, the pollution concentration, the ideal combinations of NBSs, and we also score the concerns of citizens and of the knowledge through the analytical part, knowledge gained through the analytical part of the work, to have this map of different concerns specifically tailored for this site. So we have here the Greek demo site we are working, where we can see the combination of different concerns that are then influencing an understanding of severity of each of the concerns and giving us the methodological reading of the possible interventions we can have, and really prior to the detailed analysis give us a support to then going through the further stages of modeling and design, and hopefully the realization of the project. To finish with, we are continuously working on dissemination and extrapolation of our work. We truly believe that sharing of knowledge and experience is something that will help to all of us to continue the work and to better understanding the crisis that we are living, and most importantly, to try to find the solution on local and also on the planetary scale. Thank you very much for your attention.